Hi, everyone. Welcome to today's webinar, Giving Power to Users with GSA. Now, we are going to give it just a few minutes for everyone to arrive. We are expecting quite a large number of people today. And so if we just give it a few minutes for them to turn up before we start. In the meantime, we would ask if you could drop into the chat where you are in the world right now. So we want to see how big of a reach we've managed to achieve with today's webinar. So just, city, country, whatever it is, just drop it in the chat and we'll be able to see where you are and we'll go take it along from there. So it's starting to see number in the UK. We've got London, south of Sweden, Stuttgart, Nottingham. So certainly a European reach. And of course, Newcastle and someone from India. Right, so it looks like we're getting out to quite a number of people in different parts of the world. So we'll start today's session fairly soon. But at the end of today's session, what we would like you to do is to save your questions for the end of the webinar today. So if you could put your questions into the Q&A, which you should see across the ribbon at the top of your screen, and then we will answer those questions at the end. If you don't have the Q&A button at the top of your screen, if you could place your questions in the chat, we will then move the questions from the chat into the Q&A internally to make sure that you're answered. We will endeavour to answer all of your questions today at the end of the webinar. If we can't get to them all, we will email you responses at the end. Okay, so what we'll do now is I'll hand over to my colleagues. So we've got three presenters today. We've got David de Koning, who's our head of structural products. We've got Aditya Tiwari, our senior product manager, and Angela, who our other senior product manager. All three of them here to present to you today. So without anything further, I will pass over to David. David, take it away, please.
Thank you, Andrew. Hi, everyone. Thanks so much for joining us today. I'm calling in today from Montreal in Canada, where it's starting to get a little bit cold, and we're super excited to share with you today a lot of the work we've been doing over the past year or so and the changes we've made to GSA and our view on things. But before we get into GSA and our product, what I want to talk about a little bit is you folks or us. I started my career as a structural engineer, and today I want to talk a little bit about the generation gap in structural engineering and how that affects us. There's a generation gap in life. We had a different experience growing up than our parents and our grandparents, and there's something similar in the field of structural engineering today. So today I want to present three ways of thinking about the generation gap in structural engineering that can help us have a productive discussion with our colleagues and deliver better designs. And then Angela and Adi are going to speak about GSA, because we think that GSA is a great tool for everybody on your team, no matter what generation you're part of. So the first way of thinking about the generation gap is an attitude gap. So sometimes we think that younger engineers can think that older engineers are stuck in the mud, and older engineers don't understand why younger engineers don't want to just do all this hard work that was done when they were younger. And this can just lead to frustration and not really great discussions. So a more productive way to think about it is to think that younger engineers are waste conscious. Coming in, having grown up with computers and with what these automated tools can do, younger engineers are very, very aware of what we do as engineers that's a complete waste of time and could be done faster. Older engineers, however, have been in on job sites and have had contractors tell them off for their useless design. Most older engineers have been sued at least once. Very risk conscious, and for someone who's been around the block once or twice, it's not just whether the design is safe, but it's whether we can know that it's safe and be sure that it's safe. So this is an underlying dynamic to some of the tensions between the two generations of structural engineers. And if we can all sit around the table and talk about waste and talk about risk, we can come together and put together really great processes and ways of working. The next gap is an approach gap, and this isn't 100% a generation gap, but it's pretty closely tied. One way to approach a design is to approach it as sculpting an object. And when you're sculpting an object, if you think of, sculpting something out of marble, you start by making an imprecise form of the sculpture, but it has to be correct, because if you take out too much, it's too late. You can't go back. So, some design processes are at a scheme design. We have a very rough design. There's not a lot specified, but everything that is specified is correct. And as we go through that design process, it becomes more and more and more precise, but the correctness stays the same. So it stays correct all the way through. And at the very end, you get a design that is correct and is precise. And off we go and we build it. Another approach to design is to stand up a process. And this is maybe an automated process, maybe it's in Grasshopper, maybe you've got some VBA scripts. But when you have stand up an automated process, very early in the design process, you can generate a lot of data. You can generate all the members, all the steel and concrete elements in your building. You could generate a reinforcement layout, but you haven't necessarily finished putting all the facade loads. You don't even know what they are. You haven't necessarily coordinated this all, so it's precise, but it's incorrect, and it's incorrect. You're doing your quality checks, and you've got a big big report from your BIM team about all the things that need to be coordinated. And as you go through the design, the precision stays more or less the same, or maybe it gets a little more precise as you refine the process, but it's this correctness that becomes more and more correct. And at the very end, you get a design that is precise and correct. So at the end of the design, the outcome is exactly the same, but when you meet in between, and I'm sure you guys have had this, where a younger engineer presents a Grasshopper script and they're really proud of this script and it's really good. And there's an image partway through that shows a building that is deflecting in a completely impossible way. And a senior engineer says, that's wrong. You need to go fix that. And there's this, and there's a mismatch between the senior engineer who's potentially reviewing this object that's incorrect, and the junior engineer who needs feedback on their process and isn't getting that feedback. So if we think about object and process, that again is a way for us to think productively as a team and bring everybody's strengths together. The final gap is the way we first learned about something. Sometimes, if we had to do a lot of hand calcs and we grew up in a generation where everything was done by hand, we learned from the inside out. So it took a long time to do one calculation, but you did all the calculations. And once you were done one of them, you had a pretty good sense of how the answer would change if the inputs changed, because you sort of knew how the equations connected the inputs and the outputs and all that. Another way that people learn for the first time is learning from the outside in. And, I'm sure you've all heard people complain about these young punks coming out of university and they only know how to use finite element programs and they don't understand. And maybe, but at the same time, when you have a model and you can easily change parameters and rerun it quickly, you can actually experiment with it and you can learn from the outside in. So these are three gaps. And in fact, they're not so much different approaches that are set in stone, right? To be a well-rounded engineer, you need to be able to think about risk and waste. To be a well-rounded engineer, you need to be able to think about the object you're designing and the process you're using to design. And you need to understand your analysis and design calcs, both from the inside, how does it work? What's the, how do all the calculations work? And from the outside, if I change things, how do things interact? So we hope that in presenting these three ideas, they give you some tools for discussions with your team, so that you can bring all your team members together and have a discussion and have everybody be able to contribute to the designs that you do and the structures that you bring into the world. And with that, I'm going to hand things over to Angela to talk about GSA Desktop. Thanks.
Thank you, David. And as you might notice, the sun is just rising for me. I'm all the way based in San Francisco, and I'll be spending the next little bit talking about GSA and how we can give power to users through the use of GSA. So GSA, as you may know, stands for General Structural Analysis. And that's exactly what it does. It enables users to flexibly model any type of structure, analyze it, get the results, and then design it accordingly. So what I'm going to talk about today is how we give control to the users to make a lot of these decisions. So first concept in GSA that I want to share with you is the concept of having two layers to represent the same structure. So in GSA, we have both the design layer and the analysis layer. So in the design layer is where you would consider the physical geometry of an object and kind of the components of it as a whole. We call these members. So a member in this case represents the entirety of that plate, that steel plate that is being modeled and highlighted on the left. Now, in the analysis layer is when you then take that physical geometry, that member, and you mesh it and you change it into this analytical elements that you want to analyze. So those are finite elements in here, quad 4s and tri 3s, things like that. And this is where you're able to then interrogate exactly why the model is behaving the way it is, and you have control over that. So this concept in GSA, you can apply it to a really complex geometry or to a simple structure. So on a more simple building, for example, something that you may do is you may first bring in the geometry from BIM. In BIM, everything is modeled, one entire column, one entire beam, the entire floor slab with voids. You can bring all of those in. And then what GSA will do is that it will then mesh it and create the finite elements needed for analysis. So then if you needed to interrogate anything in the analysis layer, you can look at things, the connectivity, things like that, on an element by element basis. So what this enables is this perfect balance between being able to easily manipulate the structure and also the ability to really have control over what is going on in analysis and interrogate it and understand the structure and really understand how that model is behaving. So in the design layer, you're able to easily create the geometry in the loads, able to carry out the design of the members, and also easily transfer information to and from BIM. And then in the analysis layer, that's when you can go in and really tweak any details if you need to put in constraints, things like that to get the behavior that you're really after. And then also evaluate and understand what is happening behind the scenes, because we expose that analysis layer to you. We let you see all the things that are going on inside. And so giving power to the user really is about giving each user what they want to do and make them be able to do that easily. And so with GSA, if you, for example, want to create geometry and really just work with the model fast, well, you can actually minimize the waste of time by using the design layer as a start. But then for those engineers that are looking to tweak the analysis or really understand what is going on, the analysis allows you to minimize the risks because you understand what exactly is going on inside GSA. So this is the overall concept that GSA is built around. But we've also, what I wanted to do is to show you a couple of features that show you exactly how all of this works and how it is easy to carry out some of these things. So the first I'm going to start with is creating geometry. So this is just walking through how one might create the geometry of a slab, for example. So you may go in and you can create the member in the design layer. You can draw the entire outlines. And the moment it completes, you can see that it shows you a preview of the mesh. So that's the preview of the analytical elements that will be created. You can then similarly add a void as well. And you can see that the moment I finish drawing this void, all the analysis mesh snaps to it. And so everything nodes out. It's all a really perfect continuous mesh. And the same thing what you can do is that you can also adjust that analysis mesh. So you can decrease the element size or increase it to however you wish. And if you wish to put in a 1D member, a beam, for example, it'll also intersect and node out perfectly. And when it comes to adjusting the mesh of that beam, you can also change it and the mesh will then decrease in size locally. Another thing that you could do is that you can add columns or braces that intersect with that slab. And once again, when you do that, you can see that all of the intersection points node out. And one more final thing I want to show you is that you can create something called internal offsets, which creates a void the size of the column section, and it ties rigid constraints to automatically so that you're not getting these peak stresses. So this is just a really quick example to show you how it is easy to model geometry in GSA and how you can see all the things that are happening behind the scenes. And these are the things that you are able to do with just, kind of one click of a button, but it's able to create something that really represents your structure. And so something that we have also added in the latest release of GSA is the ability to control the type of mesh. So you can have a triangle only mesh or a quad only mesh, or you can go with the default mixed. And these are all options that are now available in GSA so that you could have better control over how your structure is being modeled. Another thing that we have done is that we have created a coordination toolbar. So what this toolbar allows you to do is to easily create those analytical elements after you have created your design layer. So the first button here is to create elements from members. We also have the ability to delete elements from members. And finally, the last one is to synchronize the two layers so that you can bring the updates on attributes or sizes or anything like that over between layers. Something else that we know is really important when it comes to creating a structure is the ability to load it. And in terms of loading a structure, there's so many ways that we can apply load, right? We can apply point loads, we can apply pre-stress, we can apply temperature loads, all sorts of things. And you also sometimes want to apply load to the entire entity. Sometimes you want it to apply to a patch. And sometimes you, for example, may want to distribute the load to the surrounding members in a one-way distribution, for example. And something that we have recently implemented in GSA that makes a lot of these choices easier is the ability to load the structure by either members or specifying the individual elements. So for example, if you wanted to load an entire member, the entire slab, you can easily just say, hey, I want to just apply the load to the member, and it doesn't matter what mesh is underneath. We're going to be applying load to every single element on that member. Or if you want more control over, a specific patch or something like that you want to be loaded, you can load this individual elements. So this gives you a lot more control in terms of how you want to set up your structure. And if you do want to load the entire member, you can do that quite easily in this latest release. And now, after loading the structure, maybe something that you want to do is to analyze it. And have you ever analyze the structure and you hope everything works, you cross your fingers, and then it tells you, no, it doesn't work? I think we all understand that quite too well when it comes to debugging a model. So something that we have in GSA is called a model stability analysis, which can help you identify areas where there may be any issues. So we have this thing called a condition number where it predicts basically the larger that number, that's where more likely the issue could be. So something that you could do in GSA is run that stability analysis and then put on the contours just to show where the issue might be. So for example, here in this column, there could be a release problem or something like that that's causing instability. So something that we try to really do is make it easy for you guys to be able to debug the model as you're working and building it so that you can spend more time doing the things that are important as opposed to finding out where the issues in the model are. And now bringing it over to looking at the results and interrogating the model. So in GSA, we have this ability to do something called a volume, which allows you to really get down to the specific area that you want to take a look at. And you can also unvolume to go back to the main structure. And something else I wanted to show you is our really flexible contouring system. So we have many, many things that you can contour. This is an example of just a footfall analysis results and velocities. And you can see that you can create the contour and then select the area where you want to look at the individual numbers. And also you can really have a lot of control in terms of adjusting those contours. So you can select the number of colors, you can even select the colors themselves, select the values, create the scale that you want to create so that when you then create the visual, it is representative of the way that you want to share the structure, whether it is in a report or just sharing it with a client can really help you see exactly what each color represents. And in addition to contours, we of course also have the usual diagrams, which are, like the moment diagram or the shear force diagram. And inside GSA, you can actually see both of them together at once. And this is just an example of two different diagrams that you can overlay on top of each other. But in reality, what you could do is that you could have this, you could put the loading diagram on top of that, you could put the axial force diagram on top of that, you can even put in a contour as well. And it really allows you to see what is going on in the structure because you can see how each component interacts. Does this shear diagram make sense with this moment diagram? You can ask these questions and see them all together at once. And finally, one other way of getting results is often through tables. You want to perhaps look in and extract some results and put it into Excel, match a couple of things together to do all the processing that you may want to do. And in recognizing that, something that we've heard about a lot is that users often want to combine various parts of things together. So things that currently are in different tables. So something that we have put into the latest release of GSA is the ability to do custom output views. So what this means is that you can then create a custom output, select things like the section name, section area, axial force, and skill utilization all together in one output, and it'll create a singular table that has all of those columns needed so that you don't have to match all these tables together. It's already matched together for you. And then finally, after interrogating the results, the next thing that someone might want to do is to carry out design. So in GSA, our concrete design is super versatile. So what this means is that you can handle any direction of rebar, even if they're not 90 degrees to each other, any shape of the slab as well. So one of the recent projects that was designed using GSA's concrete designer is a Gilder Center in New York. And you can see the shotcrete walls here, how there are all kinds of shapes. That's something that GSA is able to handle. And similarly with steel, we have the ability to design any type of member with steel, and it's all the intermediate results we have made as transparent as possible. So for example, something that an input variable that you often want to look at is the effective length. Well, we have the ability to contour the effective length in both major, minor, and lateral torsional buckling axes so that it allows you to interrogate the model and truly understand how everything is working and gain trust in it. And so finally, at the very end, something else that we have put in is a website that contains all of this information. So everything that I've shared right now, everything that's in GSA, all links now to this website. So you can use this QR code. You can even pull it up on your phones or something like, and all of that. So what this website does is it collects all the information that we have about GSA, all the tutorials and all the theory behind it, and we put it all onto one site. So you can see some things from, very beginner-oriented tutorials that have a video and show you step-by-step how everything can be done and how the model can be created, all the way up to theory, which talks about the equations behind something like footfall analysis, so you can truly understand what is going on. So that is it for my section here. I will now pass it on to Adi, who will be talking about the Grasshopper plugin.
Thank you, Angela. And I'm joining today from Leeds in the UK. And I'll take you through the Grasshopper plugin for GSA. So first, quickly, what is the GSA Grasshopper plugin? Well, in a sentence, it's a parametric FEA plugin for Grasshopper. It brings the solver of GSA inside Grasshopper, as opposed to linking the two software externally, even some sort of an export and import mechanism. This means that you can do everything, that is, start from building an analysis model, load it up, do an analysis, view the results, and do further post-processing all inside Grasshopper because of the fact that the solver is inside Grasshopper. So a consequence of doing this is that all the usual suspects you might have, that does it integrate with form finding in Kangaroo? Like, yes, it does. Does it integrate with a Galapagos optimization? Yes, it does, as you see it on the screen. And more things like Octopus, policy, any of the usual workflows that you might associate with Grasshopper integrate very well with GSA. And we are one of the first ones to have actually gotten a professional FE solver integrate seamlessly in the Grasshopper environment with all of these versatile Grasshopper plugins. So while this is where things stand today with the plugin, I want to take a step back and tell you about how it all started, because we've been developing this for about 4 or 5 years now. And back then, the question which we started with to develop the plugin was, how can my colleagues who are new to Grasshopper open and check the calculations which I did in Grasshopper? So we were discussing this earlier, that we have structural engineers who are at a senior level or a mid-senior level who have been working in the industry before Grasshopper even existed. And there are some junior engineers who are everything about Grasshopper because of the kind of things it lets you do. So we wanted to build a plugin or something or a platform which would help the entire team to leverage the power of Grasshopper without the Grasshopper skills of the team being an impediment. And how did we solve this problem is by, well, simply put, let's say a senior engineer who has made a scratch model in GSA. This model can be opened directly in Grasshopper, as you see with a single click. An existing GSA model is brought in Grasshopper. You can extract all the data and metadata associated with the GSA model in Grasshopper and take the, let's say, refining the model forward or doing further analysis in it forward. So that's the first direction of the street, that any GSA model can be opened with a single click in Grasshopper in such a way. And the other direction is that, let's say you have an existing GSA model, you open it in Grasshopper, and then you do some changes to it. Like in this example, I have an existing GSA frame, which I somehow warp to make a complex geometry. And then I want this reviewed by a senior colleague. So I can just save the model as a GSA file and open the model again in the GSA main desktop application, and then share the GSA file around with my team where I might want to get the model reviewed from. So this is the simple idea. All of this is again possible because it's the GSA solver inside Grasshopper. Or maybe a good way to see it is that there's one GSA solver and your two platforms to use GSA, Grasshopper and the GSA desktop app, and you're able to seamlessly move between these two platforms by sharing GSA files. And this is how we think the entire team can use all the products together. People who are more comfortable with a more traditional FE environment that can work with GSA, and people who want to push things forward with the Grasshopper environment can use the Grasshopper plugin, and everyone can collaborate by simply sharing files with each other. So I hope this gives you a sense of how we develop the plugin. I'd like now to take you through some of the features of the plugin and how you can some of the components in Grasshopper, which I think you might find useful. So at a high level, just like any FEA analysis, you need geometry, you need materials and cross sections. You apply supports and loads to this assembly, take it to a solver, get results in both tabular format as well as graphical format. And this basic FE concept is applied as is in the GSA Grasshopper plugin as well. But while you're building the model, let's say you have to build a model, you would start probably by assigning cross sections to your model. So when you're applying the cross sections, we have made plugins which first highlight the units which you are building the cross section is, so that you're sure about they have not made many mistakes in setting up the cross section size. You have quite a lot of cross section shapes to choose from, as well as the entire standard catalog of steel sections, which is available in the main GSA software. And that's also available as it is, so that you can use a universal beam or something in a W shape, etc. The entire catalog of steel sections is available for you right off the bat to this start. Not only having the catalog of sections, you can also visualize the cross sections in 3D so that you're sure that the model which you're making is sensible and you're not made a mistake. And if you want to move the location of the, let's say if you want it to be a little eccentric so that you put it at the top or the top left, etc., you can choose the insertion point of the cross section also and visualize that in 3D if you're building slightly more complex model with eccentricities, etc. Next, once you've done the cross sections, similarly, all the standard code materials are also available for you right in the standard components, cutting across different design codes and cutting across different material types. Everything is available for you right from scratch. Now, when you're building the geometry, so the same powerful GSA measure which Angela showed you earlier is available as it is in Rhino and Grasshopper. So we all love Rhino, and Rhino is great for meshing, but Rhino struggles with FE meshing, which is the same problem that the meshes which Rhino breaks the objects down into, they should all node out for an FE analysis. And this is what we've solved here. As you see, any intersections between surfaces, lines, points, even NURBS curves are all solved for you in real time at a very high speed. And every intersection is neatly solved, as you see it here. Even all the surface nodes, all the point nodes, etc. Everything is noding out for you to make the geometry modeling easier. And just like in GSA main software, you also have an options to choose from the mesh shapes, either triangular meshes or or quad meshes, or a mixture of triangle and quad meshes. The same option is available for you here in the Grasshopper plugin as well. And now let's say you're starting to do a linear analysis. So first you want to load the structure so you can quickly display the applied loads to make sure that the loads are correctly applied or the right elements and members. And you can even display the values of the loads to see that everything in the model is. This also helps someone like a senior engineer to quickly review if the model you're building in Grasshopper is actually going in the right direction. And let's say you've loaded the model, you've finished everything, now you've done a linear analysis, now you want to see the results. So you can visualize the results either as contours, where you get to see the color plots and a legend associated with the color plot to make sense of how the results are, but also the more traditional bending moment and shear force diagrams are also implemented. So if that's the output you would need, that's available. And you can annotate these bending moment diagrams as well to show the max and min values. So while that finishes a typical linear analysis setup, what you can also do with the Grasshopper plugin with the GSA Grasshopper plugin is some more advanced analysis like modal analysis. You can get the mode shapes for buckling modes or for free vibration modes, see the associated eigenvalues, which are either the buckling factors or the natural frequencies. And this makes sense for a Grasshopper scheme design stage where you might be parametrically changing the geometry and you want to make sense of whether the geometric option you have is going in the right direction from a dynamic point of view, for example. Similarly, you can do a footfall analysis in GSA Grasshopper as well and get the key results of this analysis, which is the response factor, both the resonant and transient response factors, which can be plotted as contours on the mesh in Grasshopper. So this again makes sense for something like when you're selecting between different slab options and you want to design the slab thin to save material, but the thinner you go, the slab becomes more and more sensitive to vibrations, and you can get now the feedback on the vibration performance between the different schemes of your slabs all in Grasshopper. So let's see how all of this comes together in a workflow and a quick workflow. Let's say here's a sample building which you want to check the flows for. So you start by making a sub-model from the global model. The mesher takes care of all the meshing between beams, columns, slabs, etc. for you to make a nice sub-model. You can apply the supports on the edges of the slab to model the restraints from the facade. Then you have done a modal analysis of the sub-model to make sure that if the mode shapes are looking correct and that you get the right frequencies in the expected range. Now you want to do a footfall analysis, but you also want a review from a senior colleague or from an expert colleague who doesn't necessarily engage with Grasshopper, but you need their feedback on footfall analysis. So you can just open the model in GSA, and there you have the sub-model which you created. You have all the results ready for you from the mode shapes as well as the footfall analysis and the response factors, as you see here. And then this GSA file is what you can maybe pass around with your colleagues, get feedback on. And once you have something, then you can come back to the Grasshopper environment and continue the loop of design until you converge to a sensible design. So I hope that gives you a sense of all the possibilities that GSA and GSA Grasshopper plugin together open up for you and your team. I would like to leave you with this one idea that, well, the GSA Grasshopper plugin is one of the Oasys Grasshopper plugins. We also have Compass and AdSec Grasshopper plugins. AdSec is something which you can use to analyze concrete cross sections. Compass is something which you can design composite steel beams with. So I'd like you to think for a moment about a workflow where you go from global analysis to local analysis and design of individual members, all within Grasshopper. And once you finish this entire structural design, you can pass it forward to Revit, Excel, and Tekla, something for further coordination. We did a webinar last year, which we'll drop a link to in the chat to give you a sense of how GSA and AdSec Grasshopper plugins can together make an integrated workflow in Grasshopper, which I hope you find interesting. If you have any questions, please reach out. And at this point, I'd pass back to David for the final conclusions.
Great. Thanks, Adi. Thanks, Angela. And yeah, we hope you enjoyed this whirlwind tour of GSA and the things you can do. And I hope you find it useful, whether you associate more with the grandmother on the left or the young punk on the right. And with that, I'm going to hand it back to Andrew, and I think we'll be moving to a Q&A section.
Yes, thank you, David. So yes, we will be now going over to our Q&A session. I should be able to see the Q&A shots fairly soon. What I'll do is I'll start reading those off from the bottom, but don't feel that you can't keep adding them as you go along. So let me just get down to the oldest ones, and I'll start from there. So the first question for the panel is from Olivia. And she's asking, oh, will this be recorded for later use? Yes, it will. And we'll send you a copy or a link so that you can do that. Right, next question is regarding the RC design layer. Are there plans to enable GSA to undertake long-term concrete design, i.e. considering cracking and creep? Current and we use in-house spreadsheets at the moment with macros. So they're looking to see if GSA can relieve them of that pain. What do you think, guys, for the future?
It's an absolutely great question. So this year, what we're doing as a team is taking a deep dive into the requirements around concrete design, and in particular, we're looking at the sustainability considerations. You know, concrete behavior is quite complex, as you all know, and there's actually a lot of room to move as a designer in terms of flexibility if you can have a really sharp analysis of the concrete. So what we're doing this year is doing a deep dive into the main requirements, the main needs, the main understanding. We're structuring the product to get it ready for this sort of thing. You know, cracked concrete is obviously a big part of that. And then you should expect to see throughout the next year updates around, you know, concrete design. We've got a very generic designer that can handle really, you know, crazy stuff, and we're hoping to bring that power down to some more specific use cases.
Great. Okay, thanks for that one, David. Another question now is right, can you analyze human-induced vibration for laboratories? Well, the short answer to that is yes, you can. And as far as structural products go, GSA is probably among the best for human-induced vibration. So I'm going to move quickly on then to the next one. And of course, Shannon, if you'd like to trial the software and look at that for yourself, you certainly can. Right, so next question is, how do I use GSA with Grasshopper? And David, I'll hand it over to you.
Yeah, so I won't go into detail right now, but I did drop a link into the chat to the tutorials. We have a set of tutorials and then a set of deeper how-tos on the doc site. It's all very simple. If you have GSA installed, you can go to the Rhino package manager and search for GSA and click install, and you are off to the races. It's really quite simple. And it's bundled as, it doesn't get installed with GSA, but with the GSA license, that includes being able to use the Grasshopper plugin. So it's not an additional purchase. It's part of GSA.
Great. Next question is, can you plug GSA into Revit for analysis and design?
And again,
I guess that's for
absolutely.
you again, David. Yeah.
Yeah, GSA comes with a Revit plugin that allows you to transfer back and forth from Revit into GSA. And as Angela spoke about with the design layer and the analysis layer, you can just bring your BIM model into the design layer, and then you get control about how that gets meshed and how that gets analyzed. So we sort of rather than trying to do structural analysis in Revit, we say, yeah, just bring the BIM in, and now you can be in control as a structural engineer.
Right. Okay. The next question then is first complimenting us on the great content in GSA. Thank you for that. So does the substructure extraction from the global model include support stiffness, or does it assume rigid boundary conditions at the section cut?
I think that one's for Addy.
Yeah,
Addy?
you could do either. It's a short answer. You could apply rigid supports if you want to have fully fixed and pin supports, but if you'd like to have flexibility, the spring supports are also possible. So it's really the kind of modeling choice. But we offer you both, and both are possible with the Grasshopper plugin as well, if that was a question. So yeah.
Okay, great. Thanks for that, Addy. All right, do we have cable analysis in GSA Grasshopper, and can we assign pre-stressed values, are large deflection analysis available?
So that's three questions, and the answers
It
are
is.
yes, and yes, and yes. So absolutely, we have a great form finding capacity within GSA, whether that's for finding the shapes and doing analyses of cable nets or fabric. That's all built in there.
Okay, great. And as I said, I think earlier, if anybody watching wants to trial now that we've answered the questions and you see the answer is yes, if you'd like to trial the software, do get in touch with us, and we can help not just help you through the trial, but show you actually how we achieve the answers to the questions that you're asking. So next question then is there any issue with overlapping mesh elements for 1D element and 2D element? For example, flat slab and edge beam in terms of stiffness and this force distribution?
Yeah, I can take that one. I mean, speaking as structural engineers, yes, there is an issue and you do need to be aware of it. And that's one of the reasons that we make the analysis layer visible to you. And so we allow you to tweak and override that and model it however you like. You know, do you want to model the slab just as a load panel and then have a full beam and you can define that beam as like an L or a T beam? Or do you want to set the beam as an offset and just model the stem? You can do that as well. So all those options are open to you. And what we aim to do with GSA is make that transparent and make that scriptable so you can set up an approach for your project. And as the BIM changes, the decisions you've made about how to model the structure will then be carried through the rest of the workflow.
Okay, great. Okay, we have another question then. Can we analyze composites with custom values? So carbon fiber, bamboo fiber composites, and create custom materials for the same?
Yes, you can absolutely set custom materials for any kind of material you want. Absolutely.
Okay, great. Moving forward then. Right, there is more. There's another one just come in. So, right. So, someone who's new to GSA asking, along with Grasshopper, does it have any other APIs? Their second question: is there any study done for RMS acceleration response of Grandstand? Yeah.
Mm-hmm.
And lastly, does it cover Indian standards for design?
I'll take the first two. So one of the interesting things about the Grasshopper plugins is that they're actually open source. You can go look at the code for that. And the reason for that is that they use a .NET API that comes with GSA. So everything you can do from the Grasshopper plugins, you can do via our API. And our API is available, and the docs for that are on our website as well. So yes, absolutely. If you've mocked something up in Grasshopper and you're saying, I wonder if I could write a script that does this, the answer is yes. All that capability is there. Can you do a study for RMS responsive grandstands? Yes, GSA has been used for footfall and human-induced vibration for many grandstands. Absolutely. And then in terms of the Indian standards covered within GSA, Angela, Adi, do you guys have the specific ones?
Yes, so both IS 456 for concrete, IRS for the concrete bridge codes, as well as IS 800 for steel, both working stress method in 1984 and limit state methods from 2007 onwards, available in GSA.
Brilliant.
Okay, and then moving on then. Sorry to keep you waiting. Right. All right, so can Grasshopper generate elements capable of tension and resistance only?
So yes, GSA has strut and tie members that can take just one or the other, and those are available through the API and through Grasshopper. Yep.
Okay, and the design on our design tool, then I'm assuming then that there's many different countries the design tool is compatible with, or different country codes. Is that right?
Yeah,
So someone's actually just asked which codes can we design for. So it'd probably be easy to say which we don't, wouldn't it?
So I think the easiest thing,
yeah.
rather than reading out a list, I will drop just a link to our documentation that shows the design codes we have for steel and concrete. So that's in the chat. Hopefully you guys can all see that, but we have design codes available all around the world. And particularly our coverage of the steel design codes is very strong.
Terrific. Okay, now someone's referring to all of you as ex-colleagues, so this should be an interesting question. So it says, thanks to the team, especially to David and Angela and Daniel P., my former colleagues. What version of GSA is launched at the moment? And the design features to Concrete, has it been added to this version?
Hey, Hussein, great to have you here. Hope you're doing well. So the current numerical version, if you want to check about GSA and say, do I have the latest version? The absolute current hottest latest version of GSA is 10.2.1. But if you have 10.2.0, you've got most of the features as well. 10.2 is the major release. We aim to release new versions of GSA every 2 months. So if you're a GSA user, keep an eye out. Mid-November, pester your IT group, and mid-January, mid-March, there'll be new versions of GSA coming out. And yes, the concrete design features have been available in GSA for a number of years, and they continue to be available there.
Okay, excellent. Next one then. Can we composite deck on GSA, and especially for footfall vibration, or is there some type of stiffness modifier that we need to apply manually?
Peter?
Yeah, okay, that's yeah. So we have a composite deck option in the slabs. This is a isotropic option, and you can then add in the orthotropic material to take into account in the, for the vibration in the non-span direction. So both.
Okay, this is an interesting question here, so I'm going to read this out, and I think we'll take input from everybody on this. It says here, as I am working for a very long time with Tekla Designer, Stard Pro, eTabs, with all my other projects, what will lead me to change? What is the main benefits that we are not available in the softwares mentioned above?
Yeah, I mean, we love our software, so we could go on for hours about this, but I'll just lay out two of the primary things that we think really differentiate and where we have an opinion that we want to bring to our software. And so the one is, as you saw, all the Grasshopper plugins and the way that it's automatable, and that we don't consider automation to be some other thing you do over there, whereas and then over here you're working on the models. We want to bring everyone together and have a common workflow. We don't see a dichotomy between those two. So if you're looking to have an integrated workflow where some of what you do is automated and some of what you do is manual, we can support you in that. And the other thing is we believe very strongly that we are not writing tools to do structural engineering. We are writing tools for structural engineers. So GSA is not going to come and basically de-skill your team. We want to provide tools for you to be efficient. We're obviously very waste conscious, and on our forward roadmap, we have a lot of things around efficiency and delivering projects effectively. But our fundamental value is that if you, as a structural engineer, want to differentiate in the market by being able to do particular analyses and having a deep understanding of structural engineering, so when people come to you to do those tricky, crazy things, GSA is there to support you. And that you're not going to run into limits of what you can do with GSA. You can pop the hood open, you can build a funky analysis model, and you can understand your structure, and you can bring an amazing design to the market.
Great. I think actually, Neve, if you could get that person's details, possibly a presentation to that person might be the best way to handle all the different things that we can do.
Can I quickly compliment that
yes,
answer? That since you mentioned Tekla structures, well, there's the Tekla structures Grasshopper live link, and it's coincidental. I was just in the recent days testing the connection between Tekla structures and GSA Grasshopper. You can go from a Tekla model to a GSA model in less than 5 minutes, whether you start a model from either direction, and it's all working in a sort of a live link, which credit to Tekla structures for developing the Gate plugin. And the plugin we had developed integrates quite well with Tekla structures as well. So that might be something to try as well. Yeah.
Okay, great. But yeah, do get in contact for a personal demo. Right now, also, can we give an example of interaction GSA with Python scripting?
Yes, absolutely. We're getting close to being ready to release this. We have a module called GSA Pi, and it's a Python package, and hopefully within a month or two, you'll be able to say pip install GSA Pi or pip install GSA and be off to the races. And so this is something that's been trialed, internally within Oasys for a number of years. And recently as well, one of our teams has been supporting the analysis of the main cross at the top of the Sagrada Familia in Barcelona. And that was used by driving GSA via Python script. So yeah, that's absolutely 100% possible. We've got some stuff coming out soon. If you want to jump into it real soon right now, please reach out to Andrew. We'd love to give you some early access and help you with that.
Okay, great. I think we're running towards the end of the questions now. Will you add tapered section modeling with the new release?
So we have tapered sections in GSA. And I believe, Addy, are those in Grasshopper as well? We'll double check, so, yes. But it's certainly in GSA, yes. And absolutely, that's been there for a number of years.
Okay, and then look what looks like the final question. They're asking if there's a specific module just for timber engineering, or whether you would use GSA for all of your timber engineering.
Yeah. So GSA has been used for a large number of timber engineering. We are currently in the process of looking in particular to tie to our strength in footfall to make it easier to model CLT slabs and do a footfall analysis of CLT, especially since cross-laminated timber floor systems are vibration controlled very often. So that's something that we're looking to in the next little while. But at the moment, we don't have a one-click timber design. So.
Okay, that looks like all of the questions. If anybody has any more, obviously just send them through to us, and then we'll get back to you with an email. But that looks like, yes, that does look like our final question. So if there are no other questions, I think we will now wrap up for the day. Oh, hold on, something says. Seismic analysis. Does it cover seismic analysis before we go, guys?
Yes, you can carry out response spectrum analysis within GSA. We do not at the moment have a nonlinear time history facility, but your simpler structures with the response spectrum analysis, you can absolutely carry out within GSA.
Okay, great. Okay, well, that is the last question. So I guess that will bring us to the end of today's webinar. So thanks very much to our panel, obviously David, Angela, Aditya, and Peter. And thank all of you for attending today. And as I said, if there's any questions or if you'd like a demo or anything like that, please get in contact and we'll arrange a deep dive with you and your colleagues. Thank you very much.
Thank you.
Thanks all. Take care.
Yeah, thank you.
Bye.
Thank you all.